Today we begin section 8.6, which is solving rational equations and inequalities. Today we're just doing the equations part, but when we say solving rational equations, it's simply equations that have fractions in them, okay? So there's two ways of solving equations with fractions in them, and of course you should know this from Algebra 1 already. One way is to get rid of one fraction at a time by multiplying everything by the denominator of that fraction that you want to get rid of. Or you could get rid of all fractions at the same time by multiplying everything by the LCD. I want to show you both ways. I want to do the same problem with both ways, and you guys, whatever you feel more comfortable with, that's what you want to go with. So here's getting rid of one fraction at a time. Which fraction would you like to get rid of first? Pick one. It doesn't matter which one. We're going to get rid of all of them, but pick one to get rid of. 3/4. Okay, so how do we get rid of a fraction? Well, what is a fraction really? It's really 3 divided by 4. So if you don't want the divided by 4 part, it'd be cool if it were just a 3x, right? All you have to do is get rid of the divided by 4 by multiplying by 4. So whenever you want to get rid of a fraction, multiply by the denominator of that fraction. And not just that fraction, multiply everything by the denominator of that fraction. So put a times 4 over here and a times 4 over there. And of course, the 4's will cancel because 4 divided by 4 is 1. The fraction is gone. There it is, 3x. Now, right here, luckily, the 4 and the 12, that could actually reduce, right? Now, if this would have been a 7, then you would just put 4 over 7. You'd multiply 4 times 1 and put it over 7, if this were a 7. But it's 4 over 12, and you could actually reduce 4/12, and you might as well reduce it now to make your problem easier. So what does 4 over 12 reduce to? 1/3, right? So 4 divided by 4 is 1, 12 divided by 4 is 3. So what I have left is a 1 over 3. So it's really a minus 1/3. So here's my new second fraction. Equals, and over here, 4 over 8, that reduces down to 1 over 2. So I have equals 1/2. Are you with me? Let me pause right there. Let me ask you if you understand what I did. Did you understand what I did? Any questions? So let's get rid of the other two fractions. Which one do you want to get rid of now? The 1/3 or the 1/2? 1/3. Okay, so how do I get rid of 1/3? I multiply everything by 3. That times 3, even the 3x times 3, and that 1/2 times 3. Everything by 3. So the first term, the 3 times 3x, this guy, 3 times 3x, that becomes a 9x. And then right here, this 3 up here and that 3 down there cancel out. That was the whole purpose of multiplying by 3. The denominator cancels out. You have no more fraction. It's just a -1. Then we have equals. Now over here, you can't cancel the 3 with the 2. So right there, you actually have to multiply 1 times 3. You're going to end up with a 3 up on top, and it's still over 2. So we have the third fraction to get rid of, right? We already got rid of 2 of them. We're at the last fraction. What do I do to get rid of that last fraction? Multiply everything by 2. This times 2 cancels out. The 1 times 2 and the 9 times 2. So our new equation will be 18x minus 2 equals 3. And then from there, you just do what you always do. Plus 2, plus 2. You end up with 18x equals 5. Divide by 18 on both sides, and x equals 5/18. But what I really wanted to show you is how to get rid of fractions by multiplying everything by the denominator of the fraction that you want to get rid of. And in this example, I got rid of one fraction at a time. Okay? I got rid of the 3/4 first. I could have gotten rid of the 1/12 first. It doesn't matter which one you get rid of first, but you could get rid of one fraction at a time by multiplying everything by the denominator of the fraction that you want to get rid of. I hope we understand that. So there's a quicker path. Instead of getting rid of one fraction at a time, here's the same exact equation, and we're going to get rid of all fractions at the same time, but we have to think and find out what the LCD is, okay? So if you multiply everything by the LCD, all fractions will eliminate. And it will save you some time, but then again, when you have variable expressions like binomials like x minus 2 and the like quadratic trinomials, it could get a little tricky thinking of the LCD. Right here, it's pretty simple. 4, 12, and 8, what's the lowest common denominator? Okay, so if I were, like, when you add or subtract fractions, you need an LCD, right? When you add or subtract fractions, you need a common denominator. So what would the common denominator of 12, 4, and 8 be? 24, right? No. LCD is 24. because 4 could change to 24 by multiplying by 6, 12 could change to 24 multiplying by 2, and 8 could change to 24 by multiplying by 3. Now, it'd be a different story if this were a 6, then the LCD would have been 12 because all 3 denominators could change to a 12. But you can't change them all to 12, so we had to find the LCD, which was 24. So if you do multiply everything by 24, watch all 3 fractions disappear. 24 divided by 4 is 6. And up here, 6 times 3x is 18x. And then over here, we have 24 divided by 12. That's 2. And of course, negative 1 times 2, that is negative 2. And last but not least over here, 24 divided by 8, that's 3. And of course, 1 times 3 is 3. So we have equals 3. So we have the same equation that we did before, or that we had before. We just got rid of all 3 fractions at the same time by thinking of the LCD. Now, when I did ask you guys for the LCD, a lot of you kind of struggled with that. So maybe this is not the option for you guys, right? Maybe you just want to get rid of 1 fraction at a time. Maybe you want to get rid of the 3/4 first, right? By multiplying everything by 4, then getting rid of the 12, and 1 fraction at a time. So let's actually get to questions that you're going to see on the quiz and on the homework. This one's actually straight from the quiz, and it's a special problem. I'll get to why right now. Well, no, it's not that special actually. It's regular. So we have 1 simple fraction. How do I get rid of that fraction? Multiply by the denominator of that fraction that you want to get rid of, right? So I'm going to multiply by y. I'm going to multiply everything by y. What will I have left? The y's cancel. You're going to end up with a negative 12 equals y times y. Y times y is y squared. And negative 7 times y is negative 7y. So what we have here, guys, by the way, this is a question straight from the practice quiz. And right here it says, type in your answer. If you have more than 1 answer, you could type it in like y equals 5 and 6 if you have both answers 5 and 6. So just use the and symbol on this question. So please read instructions when you're doing this question on the practice quiz. But anyway, let's continue. We have here a quadratic equation. There's the original. We got rid of the fraction by multiplying everything by the denominator y. We ended up with a quadratic equation. And I hope we remember from a while back that when you have a quadratic equation, you want to set it equal to 0. That way you could solve it either with the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4c divided by 2a, or you could factor, split, and solve once it's set equal to 0. So let's set it equal to 0 first. Let's get rid of that minus 12 by going plus 12 here, plus 12 over there. We will have y squared minus 7y plus 12 equals 0. Again, I just wrote this right here, y squared minus 7y plus 12. I wrote it right there. And instead of having the equal 0 on the left side, I probably should have done it a step at a time. What I want to do up here is just rewrite it with the x on the right side instead of the left side. So here it is, equals 0. Now we really do have a quadratic trinomial, y squared minus 7y plus 12. It has an a value of 1, b value of negative 7, c value of 12. And whenever you have those quadratic trinomials that have the a value of 1, it's a great idea to try to factor with the y right there and y right there. It is equal to 0. How do we do this? We think what times what is 12, that if we combine together is the middle value, negative 7. So what times what is 12, that if you add together is negative 7?
Negative 4, negative 3.
Negative 4, negative 3. There we go. Good job. And now that you have something times something equals 0, that first something has to be 0 or the second something has to be 0. So that's where 0 product property comes in, that y minus 4, that could be 0, and y minus 3, that could be 0. So you actually have 2 answers, plus 4, y equals 4, plus 3, y equals 3. So those are your 2 answers, y equals 4 and y equals 3. Now, whenever you have answers, what you're supposed to do is go back to the original. If you have time, go ahead and plug it into all of your y spots and make sure that it ends up being a true statement, but you don't really have to do that. But one thing that I do recommend is to make sure that your denominator is not 0, because if your denominator ends up being 0, then the whole thing's undefined. So like let's say the denominator wasn't just y. Let's say the denominator was y minus 4. And when you take this answer 4 and plug it in to y minus 4, it'd be 4 take away 4, which is 0, which would cause it to be undefined. Then that would make this guy an extraneous solution. But that's obviously not the case on this problem. Right here, you actually have two answers. None of them make the denominator 0. So both of these are your answers. So on the practice quiz, please type it in as y equals 4 and the and symbol. I don't know what the and symbol is, and 3, right? No spaces between your terms. So we're at the homework that's on Google Classroom. It's a 2-day assignment. Today we're doing the rational equations, and tomorrow we're going to go over rational inequalities. So all the ones today, number 1, 2, 4, 6, 8, all the way through 24 even, and we're skipping 10 and 12. All of those are equations, and you get rid of fractions by multiplying everything by the denominator of the fraction that you want to get rid of. Of course, you could get rid of all 3 fractions at the same time, or all fractions at the same time, if you want to take the time to find the LCD, but it's totally up to you. Okay, so let's take a look at number 1, for example. Would you guys like to multiply by the LCD, or do you want to get rid of one of them at a time? Okay, so which one would you like to get rid of? And it doesn't matter which order, like just pick anyone.
3/4.
The 3/4, that's an excellent choice. So let's multiply by 4, right? Now, I'm not really going to multiply that fraction by 4. I'm just going to cancel it out, right? But of course, multiply everything by 4, even this one, even that one, everything by 4, okay? So on this first fraction, obviously that 4 doesn't cancel with that x, right? So we're going to actually have to multiply. 4 times 12 is 48, and it is over x. And then we have the plus sign, and then we have a 3 instead of a 3/4 because the 4 is canceled. We do have the equal sign. Now over here, something nice happens. You could cancel the 4 and the 2 and get a 2 left over up on top, or you could actually multiply 3 times 4, get 12, and then divide by 2. Either way, you end up with a nice, beautiful answer. What's the beautiful answer going to be?
6.
It's going to be 6, right? 3 times 4 is 12, divided by 2 is 6. Now, you might not see it. I mean, you might actually have to write it out. 3 times 4 is 12, 12 divided by 2, and be like, oh, that actually equals 6, right? Or you could have also said, okay, 4 and 2, 4 divided by 2 is 2, and then multiply 3 times 2, and that'll give you 6. Either way, you get a 6 right there. So, luckily, by picking 3/4, we got rid of 2 fractions at once. Now, we still need one more fraction, so what do I do there to get rid of that last fraction? Multiply everything by x. So right here times x, right here times x, and right there times x. Everything by x. So the x's cancel. I end up with a nice, beautiful 48, no more fraction, plus 3x equals 6x. So now I have a simple equation, algebra 1 stuff, getting x by itself on one side. I'm going to subtract 3x. New equation will read 48 equals 3x. Final step will be to divide both sides by 3. Divide by 3, giving you your answer, x equals 16. And of course, if you wanted to, you could plug in the number 16 right here, reduce this fraction, add it with that fraction. It should equal 3/2. It should verify your answer, okay? What do you guys think? It's not bad, right? I mean, it's really technically algebra 1 stuff. What do you guys think of this one? There's only 2 fractions here. Which one should we get rid of first? X over 2? Okay. I mean, you're going to have to get rid of both anyway, but okay, times 2, times 2, times 2. So on the right side, the x over 2 disappears. We have the nice x left over. And right here it's pretty nice. 1 times 2 is 2. So what you have is a negative 2. And up here, the 2 obviously doesn't cancel, so we're going to multiply 2 times x, and we're going to get a 2x over that x minus 1 binomial. So we're down to 1 fraction. How do I get rid of that other fraction? Multiply everything by what? By x minus 1. By whatever you have down here, that's what you're going to multiply by. So multiply by x minus 1, multiply by x minus 1, multiply by x minus 1. Okay? So as you can see, this binomial will cancel with that one. There's no need to multiply. That would be ridiculous. You just cancel them out. You have a nice, beautiful 2x left over. Now over here, this is where it gets a little interesting. We have a minus 2. I'm going to include that minus with the 2 and consider it a negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. Bring down the equal sign. On the right side, distribute x times x, that's x squared. X times negative 1 is negative x. So obviously, we have no more fractions, but we have a bunch of junk right here, right? Let's clean it up. Is there anything that I could combine to make it look nicer?
2x minus 2x.
That's right. This guy and this guy simply cancel out, right, when you combine them. And again, I still have a quadratic, so whenever I see a quadratic, I want to set it equal to 0. That way I could use the quadratic formula if I have to, or I could try to factor, split, and solve, which that's what we're going for. That's what we're hoping for. So let's set it equal to 0 first. How do I set it equal to 0?
Subtract 2.
There you go. Subtract 2. Thank you so much. Subtract 2. Subtract 2. Obviously, you can't subtract 2 from those x's. So you really do have 0 on the left side equals x squared minus x minus 2. And like I said, I don't really like having the equal 0 over here on this side. So I'm just going to rewrite it equal 0 on that side. Okay? It doesn't really matter. That's just me. Now, I do have a quadratic trinomial here. So I am going to factor it, if possible. And then I could split it and solve. If I can't factor, then I'm going to have to use the quadratic formula where my a value is 1, my b value is negative 1, and my c value is negative 2. But I could factor. Right here, I have an x, and all I got to do is think what times what is my c value? Negative 2. That if I combine together is my b value, negative 1.
Positive 1, negative 2.
Positive 1 with the negative 2. Good job. All right, so that's the factored form. And again, now we could use zero product property, which allows us to split the x plus 1 and the x minus 2. Say that x plus 1, that could be 0, and the x minus 2, that could be 0, giving us two answers. The two answers are x equals negative 1 and x equals positive 2. So yes, if you have a lot of time left over, or if you're bored, go ahead and plug in negative 1 everywhere there's an x and it should work out. Plug in a 2 everywhere there's an x and it should work out. Should give you a true statement. But at the very least, make sure that you don't end up with a denominator of 0, because that would make it undefined. So for example, if this answer would have been positive 1, okay, if this answer would have been positive 1, when I plug it in, 1 take away 1 is 0, that would mess up the whole equation. Okay, so if it were positive 1, I would cross this answer out. I would not include this as an answer. This is what we would call an extraneous solution. But it's not a positive 1, it's a negative 1. So I don't end up with 0 in the denominator, so both of these are my answers. Okay, so my answers are x equals negative 1 and positive 2. You want to do another? Yes, please. Okay, which one do you want to do? Anybody? Number 4? Why not? So on this one, what do you guys want to do? You want to get rid of fractions, right? Which one? Actually, both fractions have the denominator s plus 2. So what should I do to get rid of those fractions? Multiply everything by what? S plus 2. So you're going to multiply this first fraction by s plus 2, multiply this second term by s plus 2, and multiply this third term over here on the right side of the equal sign by s plus 2. Everything by s plus 2. And of course, on the right side, the s plus 2 and the s plus 2 cancel out. On the left side, the s plus 2 and the s plus 2 cancel out. So what I have left is a nice, beautiful s plus, but check this out, this plus s, maybe I shouldn't have written the plus. Let me erase that. I want to call this a positive s, and I want to distribute positive s times s is a positive s squared. Positive s times 2 is a positive 2s. And then I have the equal sign, and then I have the 5s plus 8 that comes down. 5s plus 8 that comes down. Once again, I have a quadratic equation. I want to set it equal to 0 so I could factor, split, and solve, or at the very least I could use the quadratic equation, the quadratic formula. Sorry about that. So let's get everything to one side. I'm going to subtract 5s, subtract, oh wait, before subtracting 5s, you might as well combine this s with those two s's, yeah? Scratch that. So that's 3 s's, 3s plus s squared equals 5s plus 8. Okay, I just rewrote it. Now let's move the 5s over. Subtract 5s. Subtract 5s. That'll leave us with a negative 2s plus s squared equals 8. Move the 8 over by subtracting 8 and subtracting 8. You can't really subtract it from the s's, but you really will have your quadratic equation that reads negative 2s with a positive s squared in the front with a minus 8 in the back equal to 0. Do we all understand how I got from here to here? So what do I do now? I have a quadratic equation. Could I factor it? What times what is negative 8? That if you combine together is negative 2. Negative 4, positive 2. Great. So it's factored. Now we could solve it using the zero product property. S minus 4 equals 0. S plus 2 equals 0. My two answers are S equals positive 4. I didn't show my work. I'm sorry. S equals negative 2. Now, if you pick both those answers, it's going to be wrong. Why is that? Because you got to plug it in at the very least to check that you don't get 0 in the denominator. And plugging in 4, that's cool. You don't get 0 in the denominator. But when you plug in a negative 2 right there, that'll give you a negative 2 plus 2, which is 0. When you plug in a negative 2 right there, it'll give you 0. And no matter what, anything divided by 0 is undefined. So the S equaling negative 2, that's not an actual answer. That's what we call extraneous. It's an extra answer that doesn't work. Of course, you don't have to label it. You don't have to, all you got to do is know that this right here is the only answer. S equals 4 is the only answer, okay? S equals negative 2 actually is not an answer, okay? I don't know. Tomorrow we're going to work on inequalities. Today we're working on equations. Should we try another? Maybe.
So do we have to plug it in every single time for which equation to make sure there's no changes?
So on number 20, you don't want to end up with an answer that's v equals 1 because that would make it undefined, right? You don't want to end up with an answer v equals 2 because that would make it undefined, right? So let's just solve it. And 20 is probably one of the more challenging ones. I have an equation. I want to get rid of these fractions. But what should I always start with? What have we always started with in this entire chapter? Whenever you see fractions, what are you supposed to do first? Starts with the F. Factor, right? Okay. So is there anything we could factor? Yes, this guy over here could be factored. Let's actually factor that. Check it out. Parenthesis, V, V. What times what is the C value 2 that if you combine together is the B value negative 3? Negative 2, negative 1. That's right. Thank you so much. So you don't even need to look at that denominator anymore. You already rewrote it in factored form. Okay, so now we have 3 fractions. We want to get rid of all 3 fractions. And we know how to do that. We just multiply by the denominator of the fraction that you want to get rid of. So which fraction would you like to get rid of first? It doesn't matter which one you pick. Anybody? There's no wrong answer. Just pick one. Come on. The 5v. Okay. So I want to get rid of the v minus 2 so I could have a regular 5v left over. So when I do that, I want to multiply by v minus 2. But obviously it has to be multiply everything by v minus 2. This also by v minus 2. This also by v minus 2. Okay. So again, since you guys told me to get rid of this fraction first, all I did was multiply by v minus 2. That way it cancels with the v minus 2. I don't actually multiply, I just cancel it out. Okay? Now, over here, I have a v minus 2. That's not going to cancel with the v minus 1. So what I actually need to do is distribute the numerator. So up here, 4v times v, that'll give me a 4v squared. 4v times negative 2, that's a negative 8v. And of course, that's still over the denominator v minus 1 because it didn't cancel with that denominator. So what do I have left? I have the minus sign that comes down. I have the 5v, the fraction's gone, equals. Now over here, something nice happens also. I'm not going to distribute the 2. Why not? Because I actually have a v minus 2 down here and that v minus 2 up there. Both of them cancel out. So cancels. And there's what I have left over. A simple 2 over v minus 1. So I got rid of one fraction. Let's get rid of the other ones by multiplying everything by what? There you go, v minus 1. So I'm going to put a v minus 1 up here in parentheses, a v minus 1 right there in parentheses, and a v minus 1 right there in parentheses. And it's actually quite nice because when you multiply the v minus 1 over the v minus 1, those cancel out. So what do we have left? We have a 4v squared minus 8v. Now, this part could be a little tricky. I need to actually distribute into this binomial, but this minus sign, it belongs to the 5. So if you distribute that 5, you're going to make a mistake. That's really a negative 5v. I want to circle it so you can see it. Negative 5v times v, that's a negative 5v squared. Negative 5v times negative 1, that's a positive 5v. We have the equal sign, and over here, the v minus 1 and the v minus 1 cancel out, leaving me a 2 on the right side. Now, this is a long equation. It is a quadratic equation because we have powers of 2. Let's clean it up by combining like terms and then moving the 2 to the left side, setting it equal to 0. Let's begin by combining the 4v squared with a minus 5v squared. That's a negative 1v squared, right? You don't even need to put a 1. You could just leave it as negative v squared. And we could also combine the negative 8v with the positive 5v. That'll give me a negative 3v. Of course, we also have the 2. So let's set that equal to 0. Now, notice, I'm noticing that I have a negative in front of the v squared, right? So if I move this 2 over, yeah, I have a quadratic trinomial, but I have a negative sign in front. So in this case, it might be a good idea to move it over that way. Okay, why is that? Because it'll become positive. Either way is fine though. Plus 1v squared cancels out, plus 1v squared. I want to get rid of also the minus 3v, plus 3v cancels, plus 3v. Okay, so this might be a little confusing. There's nothing left on the left side. On the right side, I have the 1v squared. I'm just going to put v squared. I have the 3v, positive 3v, and I have the positive 2. Again, nothing was able to be combined. That's why I just wrote it in standard form in order. 1v squared, 3v, positive 2. And now that it's set equal to 0, again, I like having the equal to 0 on the right side. So I want to put the equal to 0 on the right side. Now I'm going to factor and then split it and solve it. So what times what is a c value 2 that if you add together is b? Man, that's been the same combo on a lot of these questions. 1 and 2, right? So plus 1, plus 2. So if you split them and set them each equal to 0, we're going to have v plus 1 equals 0, which will give us the answer v equals negative 1. And then we'll have v plus 2 equals 0, which gives us the answer v equals negative 2. Hold on a sec, that got ugly. Minus 2, v equals negative 2. So those are our two answers. All we got to do is make sure that we don't end up with a 0 in the denominator. The negative 1 will not make that a 0. The negative 2 will not make that a 0 either. So I believe we're good. The negative 1 right there, negative 1 squared is positive 1. Negative 1 that's positive 4, yeah, that won't be a 0. Negative 2 right there, that's not going to be 0 either. So those are your two answers, v equals negative 1 and negative 2. Bless you. So with that said, guys, you should have the skills to do the homework. The homework is on Google Classroom. I do want you to do the even ones, and we're skipping a couple of even ones. And then tomorrow we'll work on the inequalities.